So hello everyone, these are the Texas Instrument Analog Screening questions. This can be asked by interviewer as well, as these are the really good questions. So in this question we have given a amplifier circuit. We can say as MOS circuit, and we have to find out this V out, and these conditions are given. So first of all, understand there is GM given, and a current is flowing called ID, and we can see that this is the diode connected device. uh, this is known as diode connected MOSFET. If there is resistance or not, this will not make any difference. So this MOSFET will always in saturation, always in saturation region. Why is that? Because for saturation we have this condition: VDS is greater than VGS minus VTH, and as no current flow in the gate, so all VD appears at VG. So this is VGS, and this side is VGS minus VTH. So it's surely less than VGS. We can say, as this is VGS, let's suppose VGS is 4 and VTH is 1. So if VGS is 4 and VTH is 1, that it will result in 3. So 4 is always greater than 3. This is true. So this MOSFET is always in saturation region. So the current flow in this branch, which is ID, it is a saturation current. So the condition for saturation current is the formula for saturation current is half V given C over X W over L V overdrive voltage per square. V overdrive is VGS minus VTH. Okay, so and we have given GM as well, so write the GM formula as well. We can denote this as KN, as N represent for MOSFET. So this KN, the GM is KN into V overdrive. One formula is this, and another formula is this: under root 2 ID Kn. This one is also for GM, and there is another one which is 2 ID and VGS minus VTH, which is also V overdrive. So this is ID formula, this is GM formula, and we can see there is one output resistance as well for the MOSFET, and the output resistance will always depend on the channel length of the circuit, like which is 1 upon lambda ID. This is I tell anyways, and there is no use for this in this question. So let's solve. This ID flows from here to here, VDD minus 2 V out. So write this equation, which is VDD minus V naught, V out ID. I am denoting this as V out upon R1. R1 is 1 kilo ohm, which is equals to ID, and same current will flow in this branch ID, and this point is V, as this is a source of MOSFET, this is a drain of MOSFET, and this is gate of MOSFET. So V source minus V in upon 1 kilo ohm as well. If we solve, 1 kilo ohm is cancel out. VDD minus V naught is equals to Vs minus V in. V in is 0.5 volt. V in is 0.5 volt, and VDD is 5 volt. Okay, I didn't mention VDD, so we can say VDD is 5 volt. VDD is 5 volt, and V naught plus Vs will become 5.5 volt. This is one equation. And uh, now ID is we can represent ID is half GM V overdrive as well, which is equals to we can equate this to this equation, which is VDD minus V naught upon 1 kilo ohm. So this GM is 1 millisiemens. This GM is 1 millisiemens. Okay, and V overdrive is V overdrive. We can explain this V overdrive VGS minus VTH, which is V naught minus VS minus VTH, and VTH is zero point 0.5 volt, zero point 0.5 volt, and this is half, which is which goes to there, and VDD is 5 volt minus V naught upon GM. We goes here, and GM is 1 millisiemens, and this is 1 kilo. It will cancel out eventually and become 1. So if we solve this, we will get V naught is V naught is V, V naught minus Vs minus zero point 0.5 10 minus 2 V naught, 10 minus 2 V naught. So if we solve, we will get 3 V naught minus Vs, which is 10.5, as this is 3 V naught, and this is our second equation. And if we solve these two equations, this is V naught minus Vs, and this is V naught plus Vs. If we solve this equation, we will get V we get 4 V naught is equals to 16 volt, and V naught is 4 volt. And now for the second question, in this we have given uh wait a minute, what is this voltage? This voltage is 2 volt. So this is a voltage source. These are the capacitor, which is C and C. All three capacitors are same, and there is an initial voltage 2 volt and 1 volt here. And when time is equal to t naught, we have to find out this V out voltage. As there is no current, first of all, if there is no current flows from this capacitor. So all this voltage appears at this node. So we can ignore this capacitor. We can ignore this capacitor, and if we solve, uh, first make this circuit. This is voltage source, and this is two capacitor, which is of 2 volt, and this is V out, and there is 2 volt. Now represent this in Laplace form. This is 2 volt, this is 1 volt, and C capacitor, and there is some current flow in the circuit, which is I. So if we represent this in Laplace form, this is uh, uh, this is a unit step voltage. Like we can say this 2 volt is look like this 2. So in Laplace form, can we can we can show the circuit as this is voltage source, and we can separate this capacitor as well. Like if capacitor has 2 volt, if capacitor has some voltage, we can denote this capacitor as a separate voltage source, which is plus minus 2 volt, and a capacitor only. So in Laplace form, this will become 2 by S, and this capacitor C, and we can represent this in impedance form, which is 1 upon SC. Now apply this here. This is 2 volt, and our 2 volt voltage source appears here, and this capacitor, which is 1 upon SC impedance, and another voltage source, which is of 1 volt, and another capacitor of 1 upon SC impedance, and this will connect to this capacitor, and this voltage source is as well 2 by S voltage. This circuit is in Laplace form, and there is a current flowing in the circuit, which is Is. Okay, now apply KVL in this loop. So if we apply KVL, which is this is minus plus, we are going from minus to plus, we will notice 2 by S. Now we are going from plus to minus, which is minus 2. We can denote this as 2 by S as well, and this is 1 by S as well. Okay, as this is in a Laplace form. So this is 2 by S, and current flowing in this resistance. So it is minus is upon SC. Another minus, which is we are going from plus to minus, which is 1 by S, and another is upon SC, and is equals to 0. So this will cancel out, and we will get minus 2 is SC, which is equals to 1 upon S. This S to S cancel, and we will get IS minus C by 2 ampere. Okay, so this is our IS, and we have to find out this V out. So this V out is nothing but this voltage source and a current flowing in this impedance, which is is into this impedance. So V out nothing but uh, uh, voltage voltage on this branch, which is equals to V out S equals to 1 upon S plus this is multiply with SC. So 1 by S plus we put the value of is, which is minus C by 2S. See, C to C cancel. So the our final answer is V naught is 1 upon 1 upon S, 1 upon S, sorry, 1 upon 2S. Okay. So if we convert this in time domain, it will become zero point 0.5 volt. Okay. So this is our final voltage when when this current is switched, and this switch when this switch move to this point at t is equal to 0 seconds. So our V out is 0.25 volt. And uh, another point is here that there is that initial charge is initial charge and capacitor is initial charge and capacitor is uh, 2C plus C, which is 3C. But after switching, there is some additional charge, like the circuit is C by C, so we can equate this as 1 upon at C by 2, and this circuit is connected to 2 volt voltage source plus 2 volt. So there is another there is some additional charge, which is Q is equal to C into V. V is 2 volt, 2 to cancel. So uh, another C charge adds as here adds after switching. So the final charges on the capacitor is 3C plus C. This C comes from the switching part, where this C is provided by this 2 volt voltage source. So thank you for the watching.